As you remember, we talked about, had a throwback to last week, and we talked about the questions about causality in the weekly assignment. Then we talked about the uses for theory. Why do we need theory? And how do we reason on the basis of theory? So ideally, what steps do we take starting out with your theory or substantive hypothesis? And how do you reason to your statistical hypotheses and back again? And I've shown you an idealized version, and with the example of the perception behavior link and the research about priming people with elderly related words and measuring walking speeds, I've already indicated that in a lot of examples, people or researchers skip a couple of these steps. And in so doing, they make a couple of reasoning errors that we might recognize from the third block. And we're going to talk about those briefly. So, first of all, a form of circular reasoning. I already pointed it out when talking about walking speeds. And so if you say walking speeds are caused by stereotype activation, and you then say, how do you measure stereotype activation? Well, with walking speed, that sounds like a circular argument, right? And that's also what's happening here. It's another research results for which the perception behavior link was used. The conclusion of the authors, so they did a research and they primed people with not elderly related words, but professor related words. And then they had a look at how well they did in a game of Trivial Pursuit. And they noticed that people did better on Trivial Pursuit when they were primed with stereotypes associated with professors. So again, the idea is the stereotype related words activate the stereotype, which makes it more likely that people start acting congruently. So you act smarter because this stereotypical view of being smart has been activated through that professor stereotype. So they concluded, in concrete terms, activation of the professor stereotype is expected to result in intelligent behavior because activation of the professor stereotype leads to activation of intelligence. That's actually their conclusion, right? So this is the theory that we just tested, and this seems to be our most likely explanation for the results. That looks like this if you put it in a formal in a standard form. Professor stereotype activation. If professor stereotype activation, then you'll become more intelligent. So if professor stereotype activation, then you'll show more intelligent behavior. But if you then ask these researchers, how did you measure intelligence? Well, with the type of answers they got correct in Trivial Pursuit, I would describe that as a behavior. And if that behavior shows a degree of your intelligence, then we're talking about intelligence behavior, right? So they also already presupposed the premises to be true, or there's no real semantic difference between the information in the premises and the conclusion, which is a form of circular reasoning, right? We talked about 3 different ways in which you can talk about circularity in argumentation. One is in which you literally repeat the premise, God exists, therefore God exists. The other is that you presuppose the truth of the conclusion in the premises. The Bible states that God exists, the Bible is the word of God, therefore God exists, right? So you already have to assume that there is something that can be called a God, which has a word for the premises to hold. And the third one, and we didn't talk about that at length, but what we just discussed is an example of that, is that in which the premise is logically or semantically equal to the conclusion, or identical to the conclusion. So if you say that Jan reacts more quickly to aggression-related words, and then conclude aggression-related words are more accessible in the long-term memory of Jan, how do you know that? Well, because of that reaction speed, right? So basically the conclusion and the premise state the same thing, only the one does it in more general terms. That can be useful, right? Basically, you're connecting your specific research finding to a general phenomenon, but oftentimes it's just a redescription of the research result in more general terms. So it's not really a test of the theory, but the theory is more a redescription of the result you actually found in more general terms. So you're saying that the concept of intelligence is activated because intelligent people because intelligent behavior was shown in one condition, and how do you know that intelligence was activated? Well, because they showed intelligent behavior. So you're measuring the supposed cause and the supposed effect with the same measure, yes, identical same measure, which makes this reasoning circular and not very informative. All right, so that's one way in which reasoning from your theory to your results and back again can go awry in this form of circular reasoning about your theory. Another way in which it can go wrong is equivocation, which you might remember being one of the fallacies or forms of pseudo-reasoning in the Bowell and Kemp book. Equivocation means that, or trading on equivocation means that the theory that you use in this case, or the explanation that you use in this case, can be interpreted in multiple ways. In this case, it would mean that a one-word explanation, as it's called in readings for today, is that the same word is used as an explanation or theoretical mechanism without further additional assumptions being explicated, even though it describes several underlying processes. So we use the same label for things that are actually slightly different. And if we're then saying that we're testing the representativeness heuristic explanation or prediction or theory, in this case, just alluding to representativeness heuristics could lead to completely opposing predictions, right? And you've actually already seen this, right? I've talked to you about the hot hand fallacy, in which representativeness is used to explain why people, expect it to be more likely that a basketball player lands another good throw, earns another point in the game, because they've already earned a series of points in the game before. That's called a hot hand, and then people have the expectation that that makes it more likely that people have a hot hand and they're more likely to land a point again. So basically what people expect because of representativeness is that they expect the same result as a previous series of result, right? So if you would at face value look at the representativeness theory, let's call it that, what would you predict? Well, there's a series of outcomes, earning points, and I expect a similar or the same outcome in the next event. That would be the prediction. But the representativeness heuristic has also been used as an explanation for why people commit the gambler's fallacy, in which, because the ball in a roulette wheel has landed on black a couple of times in a row, people think it becomes more likely that red will be the next outcome. So, in the same terms that we just talked about the hot hand, what people expect is the opposite outcome compared to the previous series of events, right? Now we have a series of black, 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 and now we expect red. So that's the opposite. We expect something else to be more likely to happen because of representativeness, even though in the previous example, we expected the same thing to be more likely to happen because of representativeness. You can be more specific about it, as I was in the first block, and say because of representativeness, we view certain outcomes to be more representative. But it shows you that on the basis of the same one-word explanation, it can lead to opposing predictions. And that's why reasoning about your theory using one-word explanations is a form of equivocation. You're basically being very vague about what to expect, and we can expect opposing results. So you can question to what degree this actually constitutes a test of your theory. All right, so in reasoning from theory to experiment, people also commit to the null ritual. You should be already familiar with that, right? So you set up statistical hypotheses of no mean difference or zero correlation, but you don't predict your research hypothesis or specify research hypotheses. You use 5% as your alpha level, and you always do this. You not only use 5% as your alpha level, but you also accept your research hypotheses if you can reject a null. So that basically states that you're skipping a step, right? Let's make that explicit. So I said that you're going for your substantive hypotheses to your research hypotheses to your statistical hypotheses and back. And if you say that in that second step of the null ritual, if you can reject a null, that basically means my theory is correct. You're just equating your statistical hypotheses with your substantive hypotheses. And that shouldn't necessarily be the case. So that's why you can call that final step in the null ritual a form of a false dilemma, right? Either I cannot reject my null hypotheses or my theory is right. Those are two that creates a false dilemma because there's more options, right? It could also be the case that you can reject a null and your theory is incorrect as well. But some other theory which would have predicted the same difference is correct. It's also a form of common practice, right? We're doing these steps in testing our statistical hypotheses because all people are doing it. Form of common practice. And it's also a straw target argument. And that final example is somewhat more difficult to grasp. Oh, sorry. Let's talk about that. So if you remember, the straw man or the straw target fallacy is a way of representing the argument of your opponent in a way which makes it easier to defeat, right? So in this discussion about tuition fees, I gave this example before. I could, let's say you students and I have a discussion about raising tuition fees, and you're saying, no, we're against that, and I could misrepresent your argument in a way that makes it weaker. I could say students only want are only against raising tuition fees because they want to buy more beer. That's not necessarily untrue, but it would be a very weakened version of the actual argument that you might have. And I represent it a way because it's easier to defeat for me in that way. And that plays a role in research as well. We already covered it, right? So we talked about a critical reader could say that, well, precognition cannot exist because it's not in line with the laws of nature or physics or whatever, right? So it's actually goes against everything in physics to say that stuff from the future influences the past. If Daryl Bem then says, well, if precognition didn't exist, then then I couldn't expect any other outcome than the result of random guessing. So 50% correct rate on this weird computer task that I just thought up. And he did find a difference, so therefore my theory about precognition is correct, right? It's a similar way of giving actually a weakened version of that counter argument, right? What we're saying, or what Jan is saying here, is not necessarily that you couldn't expect any deviations from chance in a weird computer task. No, he's saying that he's actually giving a very strong argument against the theory, basically that it goes against a lot of other assumptions in science. So saying that all that Jan is saying is that, well, here's this weird task and you couldn't expect a deviation from chance, and still I found that result, is a very weakened way of, testing your theory in this case. And the same applies to perception behavioring. The same applies for a lot of stuff that you might read in psychological publications. Basically, researchers rejecting their null and concluding whatever they like after that. And that step, in so doing, you're missing a couple of steps. What you should take away from this, in the fact that I'm calling null hypothesis significance testing as it's done in the null ritual, right? Just saying, well, I'm just setting up the null hypothesis as no difference whatsoever, and then I'm trying to reject that. And if I am able to do that, I accept whatever I believe to be true anyway. I call that a version of the straw man or straw target and false dilemma because it's a very weak test of your theory, right? It's very unlikely, especially in correlational designs, that two variables are unrelated in any way, right? So the actual correlation between two variables, there will also always be some correlation between them because of the stuff we're interested in is somehow connected, even in an indirect way. And even in experimental designs, it's unlikely that the literal null hypothesis of zero difference, right? Zero difference whatsoever between two groups is true. So if you have enough power, use enough participants, it's likely that you'll reject that null hypothesis of zero difference whatsoever. That will lead to rejection somehow, right? It might be a very tiny difference, but if you collect enough data and you have enough participants, then you will reject a null. That doesn't mean that your theory has been properly tested. That just means that you found a difference, or it's likely that you found a difference, or that you're justified in rejecting the null would be the most correct interpretation, of course. That doesn't necessarily mean that those results are most in line with your theory. So just saying that your theory is true because you were able to reject a null is a form of weak reasoning and a weak test of your theory. Let's see. Yes. So supposedly, the reason why we test theories in any at all is because of what you've been taught in the first year, right? So you have the empirical cycle of observation through deriving hypotheses, testing them, and starting the whole cycle again. And at least at a glance, it looks like some deductive reasoning is going on here, right? So we deduce certain hypotheses from our theory and we test them, and they're either falsified or not, because we can only logically falsify our assumptions and not really verify them by verifying our predictions. But that is what's happening a lot in research, right? So you do see a lot of reasoning in this manner. So if the perception behavior link is correct, then people walk more slowly towards the elevator. After I've exposed them to age-related words, the stuff we talked about. I've confirmed that prediction, so that must mean that the perception behavior link is correct, or at least it's support for my theory. But that's a weird way of reasoning, right? Because we know we can't strictly, in a deductively logical sense, conclude anything from confirming Q if we've just claimed if P then Q, right? So Q being true has no logical bearing on the truth of P, as you know. So let me see. We need to move beyond that form of deductive reasoning, right? So there's no logical reason for saying that the fact that I've confirmed my prediction, therefore my theory must be true. No, perhaps that's not what researchers mean as well. They mean to be more inductive in their reasoning about their theory on the basis of their results. But then we need additional information, right? Then we need to look at, so if it is indeed the case that the perception behavior link is correct, or this process is taking place, how likely is it for people to be walking more quickly to the elevator? Compared to how likely are the same results given that another theory holds or another process is taking place, right? So we talked about this a lot. So this should be more intuitive to you, right? So if we move from that deductive reasoning to inductive reasoning, then we need something that we can consider evidence, which is how much more likely are these results given our preferred assumption compared to any other assumption that might hold. So we need that comparison that needs to be made to make for a convincing argument about your theory in this case. So we've moved from that deductive argument, right? And we've seen again, right? So confirming your prediction has no deductive logical implications for the truth of your theory. And we've seen that, well, as an inductive argument, we need more information, but often this is omitted from the research. But you know to be on the lookout for it, to properly judge the theory in light of the data. By the way, ideally, and this is how we discussed it, falsifying your prediction, so let's say that we reason accordingly and then it turns out that people didn't walk more slowly towards the elevator, that should be seen as a falsification of your theory, right? Because falsifying Q, or denying Q, has logical implication for the truth of P, right? If P, then Q. If not Q, then not P, you should remember. So strictly in a logical sense, you could say falsifying my predictions has bearing on my theory. But that also is not well reflected in literature. So if people, researchers, are unable to confirm their predictions, they tend to backtrack and say, well, no, it must have been something wrong with the research, right? And that shows a flaw in the reasoning of Popper about falsification and the original falsification principle. What we're testing in an experiment is not just the theory that led to the prediction, but it's also different auxiliary hypotheses, or auxiliary assumptions as it's been called. So those are assumptions about your theory, but also assumptions about how you perform measurements, assumptions about how you conduct your research, etc., etc., etc. And if all those hold, then we can expect these results. And if then those results do not occur, it's still unclear which of those assumptions are falsified. Are the assumptions about the theory? Are the assumptions about proper measurement? Are the assumptions about proper sampling, etc., etc., etc.? Right, so there's a whole bundle of assumptions together with your theoretical assumptions that are tested in trying to falsify your predictions. And if those predictions are falsified, it's still unclear which exactly isn't true. Is it your theory or your measurement or the local circumstances? So it doesn't really, falsification of your prediction doesn't necessarily mean that your theory isn't true, as Popper would have liked us to believe originally. All right, so we've looked in a deductively logic way at how do you ideally reason from your theory to your prediction and back again, right? So confirming your prediction has no logical bearing, and rejecting or falsifying your prediction doesn't necessarily mean that your theory specifically is wrong as well. So deductive logic in that sense is not of a lot of use in reasoning about research results, and it makes more sense to reason inductively about your research results and trying to show that the results that occur are better predicted by your theory than by an alternative model or theory, right? Which is what we did all the time in talking about inductive inference in the previous two blocks. And that sometimes is a challenge, because ideally, again, I'm talking about the ideal compared to the reality, you would have researchers who do this all the time. So these results occurred, and that's indeed in line with what I would expect if my theory holds. But then you need to know, is it likely to happen if any other theory holds as well? And what is the difference between your theory and something else? So if you were to read research about mortality salience, which is a fancy word for thinking about dying, or being more likely to think about dying, then, so what research shows is if you make people think about death, for example, or their own imminent death, they're more likely to buy symbols of nationalism, right? American flags in this case, or Bibles or whatever. And they explain this with the concept of mortality salience. So they also, the fact that your own imminent death is more salient means that you need other reassurances of structure and something you can hold on to, which are all culturally related, such as symbols of nationalism. So that's a whole bunch of words. That would be the summary, right, of what we're deriving from those research results. But there's no comparison made to alternative explanations. So this could be considered a form of confirmation bias. We talked about this in the previous block, right? So Nusso called this a form of hypothesis myopia, right? So if I would tell you that this shampoo, it actually exists, it has caffeine in it. Again, this is my jealousy towards people with hair, presumably. It would mean, according to the shampoo, that the shampoo stimulates the roots of your hair during washing it. And so let's say that you see a beautiful effect in your hair of washing your hair with this type of shampoo. Does that mean that indeed the caffeine has stimulated the roots of your hair in the appropriate way? Or is it just a general effect that washing your hair has on how your hair looks? Right? Both would be confirmed by these research results. And we shouldn't jump to the more specific conclusion that it has to do with the caffeine extract if it could also be explained with more general explanation of just washing your hair. And if we focus on the red explanation and forego differentiating it from the blue explanation, we're confirming the confirmation bias. The same as another example would be, let's say you stick needles in somebody's back and you're saying, well, my problems with my back go away. So that must have been an observed effect of the workings of acupuncture. It could be. It could also be the effect of a more general phenomenon of finally being taken seriously by a specialist, right? Somebody's talking to you and taking your issues with your body seriously, which also has an impact on how you think about how you experience your symptoms. So basically, I'm again saying, jumping to the conclusion that it must be the effect of acupuncture means we're skipping a step, right? We're making the confirmation bias. It could also be just a general effect of being taken seriously by specialists. So if we then go back to the mortality salience, so let's say I'm offering you a vignette and I'm asking you to think about your own death, and then you're more likely to buy a flag of whichever country you reside in, right? I could say that that's a specific effect of mortality salience, right? Because you're constantly thinking about your own death, you're more likely to buy into symbols of your culture or your nation, right? It could also be a general effect of experiencing a lack of control. So, two things to take away from this confirmation bias section. One is that there should ideally always be a contrast between competing explanations. Researchers should always be trying to convince us that, well, these results occurred that is indeed predicted by my theory, but what could it also be predicted by other theories as well? which one, and why do we think that still our theory should be preferred compared to those others. And the other one is that in general, you can always think about more general explanations for the same research results. So that's one of the reasons why we should contrast competing explanations, and you as a critical reader should be able to think of contrasting explanations for the same results. Next time you read a research result, promise me that you think about, well, what more general explanations could hold as well. We'll get back to this next week as well in the lecture about critical thinking about psychological constructs. So we've seen why we need theory, and we've seen how we ideally reason from theory to results and back, and we see what goes wrong in reasoning from your theory to results and back. Different fallacies that you should be able to recognize from the previous two blocks and how they occur in how people reason about their data.